This factoring method video covers a calculus level problem where you would need to factor out the GCF and simplify. This would be the algebra that follows a derivative problem where you have had to use the product rule along with the chain rule. Okay, so we end up with two groups after having done some calculus, and we're looking between the two groups of products and seeing what we have in common, and we're going to write down the greatest common factor, and then we will write down what's left from each group. So first of all, moving from left to right, we see that we have 3x plus 2 in both groups. The first group has that factor raised to the fourth power, and the second has it raised to the third power. So I am pulling out 3x plus 2 raised to the third power. Okay, the next thing I see is a 6, moving from left to right. But in the second group, I have a product of 4 and 3. So I'm going to go ahead and multiply that together. That's 12, which is 6 times 2. So between the two groups, we have 6 in common. So we're pulling that out as part of the GCF. Okay, now the next factor that the two groups have in common is x cubed minus 4x plus 5. The first group has that raised to the fifth power, and the second group has that raised to the sixth power. So the GCF between the two groups then includes x cubed minus 4x plus 5 raised to the smaller exponent, which is a 5. And that is all that they have in common. So what we've done is we have pulled out the GCF, and now in brackets we're going to write down what's left over from each of the two big products. Okay, we pulled out from the first group, we pulled out 3x plus 2 to the third power, but the first group had that factor to the fourth power. So that leaves a 3x plus 2, but you do need to put parentheses around that factor. We pulled out the 6, and we pulled out the next factor, x cubed minus 4x plus 5 raised to the fifth. But we had one more factor in that group. It is the binomial 3x squared minus 4. And I'm leaving parentheses around that factor because we're going to need to do some multiplication in a minute. Okay, now that takes care of the first group. And so now we're writing down what would be left over from the second group after pulling out the GCF. Okay, the first factor is x cubed minus 4x plus 5, and we pulled that factor out to the fifth power, but the second group has it to the sixth power. So we have one factor of x cubed minus 4x plus 5 left. And remember, I had already multiplied the 4 times the 3, and we pulled out 6 from 12, which leaves a 2. And that is everything that was left over after having pulled out the GCF. So now what we're going to do is rewrite the GCF, 3x plus 2 raised to the third power, times 6, times x cubed minus 4x plus 5 raised to the fifth power. And now in the brackets we're going to do some simplification. The first product that you see in the brackets is a binomial times a binomial, so we can use the acronym FOIL to do the multiplication. So I'm going to take 3x times 3x squared and get 9x squared. Then I'm going to take 3x times negative 4, that would be negative 12x for the outer product. The inner product is 2 times 3x squared, that would be 6x squared. And the last product we need is positive 2 times negative 4, which is a negative 8, plus The second product in the brackets is just a simple distribution of multiplication by 2. So I'm taking 2 times x cubed, that's 2x cubed, minus 4x times 2, so that's 8x, and then 5 times 2 is 10. So we did all the multiplication. We're writing down the GCF again, and inside the brackets we're going to add like terms. And I just realized I made a mistake. Hopefully you caught that. The f should have been 3x times 3x squared, which is not 9x squared, it is 9x cubed. If you caught that, give yourself a bonus point. Okay, so now we're ready to add like terms. I have a 9x cubed plus a 2x cubed. That would be 11x cubed. I have a 6x squared that didn't have any like terms to combine it with. And I have a negative 12x and a negative 8x, which gives negative 20x. And then negative 8 plus 10 gives us 2. And I'm closing the parentheses and we're done.